Hi everyone, in this video I'm going to talk about magnetic resonance spectroscopy and ultrasound or ultrasonography. Firstly, I'll be talking about magnetic resonance spectroscopy or MRS for short. So what is MRS? MRS is a useful and widely available technique for the non-invasive measurement of tissue metabolism. Now, what is the principle of MRS? The basic principle that enables MRS is that the distribution of electrons with an atom nuclei in different molecules to experience a slightly different magnetic field. Okay, how does MRS work? MRS detects radio frequency electromagnetic signals that are produced by the atomic nuclei within molecules. It can be used to obtain concentration measures for certain chemicals in complex samples such as the living brain. In certain specific circumstances, MRS also provides means of performing kinetic analysis of dynamic neurochemical processes. Okay, what are the applications of MRS? Some applications of the magnetic resonance spectroscopy are applied in medical areas such as diagnostics, usage by organ or system, neuroimaging, cardiovascular, musculoskeletal, liver and gastrointestinal, and angiograph. Those areas have one thing in common, which is they are composed of biomolecules that have a certain biochemical environment, and those biochemical environments are useful in revealing the nature through magnetic resonance spectroscopy. Now, secondly, I will be talking about ultrasound. So, what is ultrasound? Ultrasound is an imaging test that uses sound waves to create a picture of organs, tissues, and other structures inside the body. And what are the principles of ultrasound? Number one, it is the use of sound waves beyond the audible frequencies, which is greater than 20 Hz or 20,000 Hz or 20 kHz for diagnostic purposes. Secondly, ultrasound can be used for therapeutic purposes by using larger and continuous dosages, as in number one, generation of heat, which is treatment of low back pain, muscle strains, promote tissue regeneration, and kills malignant cells. Then number two, to pulverize kidney stones and gallstones. Now, how does ultrasound work? Okay, the ultrasound machine transmits high frequency of about 1 to 5 megahertz sound pulses into the body using a probe. The sound wave travels into the body and hits a boundary between tissues, example, between fluid and soft tissues and bones. Some of the sound waves gets reflected to the probe, while sound travels on further until they reach another boundary and gets reflected. The reflected waves are then picked up by the probe to the tissue or organ boundaries using the speed of tissues, which is 1540 meters per second, and the time of each echoes with them, usually on the order of millionth of a second. The ultrasound machine displays the distance and intensities of the echoes on the screen, forming a 2D image. The images help investigate muscle pulse, tissues, tears, nerve problem, and ailments such as arthritis and osteoporosis. The applications or uses of ultrasound is used to treat soft tissues, ailments, bursitis, collagen diseases, and soft tissue injuries. Thank you. That's all. Hope you enjoyed the video and please subscribe. Thank you.